Yeah, welcome back, students. Now I'm going to talk about arrays. Already I spoke in the first session. I spoke to you about arrays and what is the need for going for arrays, how to use arrays, and what is single dimension array. Okay. And in this second session, I'm going to talk to you about what is two-dimensional array. What is two-dimension array and multi-dimension array. Okay, these are the two things which I'm going to cover in this session. Now coming to the first session, coming to this array part. What was the main reason that we were going for arrays? If you have observed exactly, what was the main reason that we have been using arrays concept over here? So instead of declaring multiple variables, say for instance, I want to declare about 5 variables. Okay. For instance, I want to declare about 5 individual variables. So what I was doing, I was declaring a variable like this int a comma b comma c comma d comma e. I was declaring 5 individual variables. So instead of declaring individual variables like this, alternative solution is declare a single variable, like declare a single variable a, and to this give the size of 5 numbers. That is, in the bracket, give the size as 5. So here, instead of declaring a single variables like this, instead of declaring the individual variables like this, what I'm trying to do here is, instead of giving the single variables like this, what I'm trying to do here is, I'm declaring a single variable and giving the size as 5. That's what I was doing. That is a concept, or that is a need for us to go for arrays. Now, coming to the continuation concept. Say for instance, I've declared an array of size 10 of 5. So let us say 5. I've declared an array of size 5. So how it is going to be? I'm going to declare an array of size 5, which is going to occupy some memory. Okay, about 5 into 4, 20 bytes of memory. Okay, and these are the values are going to be stored: 1, 2, 3, 4. So entire array is named as A. This array is going to be named as A, and individually every value is given an index. I'm talking about single dimension. So every value is given an index. Like first value is given the index 0. Second value is given the index 1. Third value is given the index 2. Fourth, 3. Fifth, 4. Right? So these are the values are given. Now coming back to the basic concept of array, why we are going for arrays. Instead of declaring individual variables like this, I am going for a single variable which can store 5 different values. Right? Now, here I have taken an array. Here I have taken a single dimension array. Same way, if I need one more single dimension array, say for instance, int b of size 5. So again, I require another single dimension array. Okay, which can store 5 different values. So again, the index is going to be same. For b, this is going to be b of 0, b of 1, b of 2, b of 3, b of 4. Okay. Now, continuation to this, I want to have another single dimension array. Int C of 5. Remember, all are having a size of 5 only. A of 5, B of 5, C of 5. So C of 5 can be taken like this. So again, index also will be same. C of 0, C of 1, C of 2, C of 3, C of 4. Right? So this is how we are going to store the things. Now, coming back to the basic concept of array, instead of declaring a single variables, I'm going for an array of size A of 5. Same way, we come back to this concept. Here I'm declaring one single dimension array, here another single dimension array, here another single dimension array. 3 single dimension arrays I have declared all together. First single dimension array, then second single dimension array, then third single dimension array. Altogether, 3 single dimension arrays I have declared. Can't I combine them and make them as one more array? Because here, instead of declaring a single variables like this, I'm combining them as a array. Again, I'm declaring the individual single dimension arrays of 3. Can't I combine them and make it as another array for array? Yes, we can. So when we combine them and make it as array for array, it will be something like this. Okay, so I want a array of size 5, each of size 3. I hope you people are able to follow me. Okay, I am going for 3 single dimension arrays. First single dimension array, second single dimension array, and third single dimension array. So what I am doing is I am combining all these 3 single dimension arrays as one. So when I combine all these 3 single dimension arrays, they are of size 5 of 3 ID. Okay, which is nothing but it appears something like this. Okay, in this I'm going to have 5 rows, each of 3 size. Okay, just a minute. Just I'll modify it. I want to declare an array of just I have taken reverse way. Int A of 3 of 5. I'm sorry for this. Okay, A of 5 of 3. So I'm going to have 3 rows with 5 different columns. Okay, so it can be like this. First array, second array, and third array. First single dimension array, second single dimension array, third single dimension array. Okay, so we have observed first single dimension array, second single dimension array, third single dimension array. 3 of them, I'm combining them as one group. In turn, which becomes a multi-dimension, or in fact, we call this as 2-dimension array. And inside every column, I can store 5 values. So inside every row, I can store 5 values. Okay, so this can be called as row This can be called as row of 0. This row of 1. As I've said, array index is going to begin from 0, and this row of 2. Just a minute. Row of 2. Okay. Now, same way if you take the columns, this can be called as column 0, column 1, column 2, column 3, column 4. So it will be like this. Col 0, col 1, col 2, col 3, col 4. Okay. Now, consider this as one single dimensional. This one is one single dimensional. So inside single dimension array, the index are going to be like 0, 1, 2, 3, 4. And consider this as another single dimensional. Consider this as another single dimension array. And this one as third single dimension array. Okay. So as the first single dimension array, it is called as row of 0. Second single dimension array, row of 1. Third single dimension array, row of 2. And columns, as we know, it is going to start the index with 0, 1, 2, 3, 4. Now, when we come to the combination of these rows and columns, the combination of rows and columns can be this particular cell can be called after row and column. So it is called as 0, 0, 0. Whereas if we come to this one, it is called as 0, 1. It is called as 0, 2. That is, they are named after row and column. This one is 0, 3. And this one is 0, 4. Again, when we come to the second row is going to begin with 1. 1, 0. 1, 1. 1, 2. That is, they are named after row and column. Row is 1, column is 2. So it is 1, 2. And this one, 1, 3. And this 1, 4. And coming to the third row is 2. Column is 0. So this one is 2, 1. This 2, 2. This 2, 3. This 2, 4. So this is how the multi-dimension, that is two-dimension arrays are going to be represented in a pictorial representation way. So when we come to the programmatical concepts, okay. So declaration of single dimension, two-dimension array can be like this: int a of 3 of 5. This will be the declaration of a two-dimension array. Okay, that is, it's going to have 3 rows and 5 columns. Now we can assign the values in two different ways. One is directly I can assign the value, or I can use a scanf statement for assigning the value. So first I'll show you how to assign the values directly. So here just keep a equal to, open a block. Okay. Now I'm having 3 different 5-dimensional arrays. Okay, I'm having 3. This is one single dimensional array, this is another single dimensional array, this is another single dimensional array. So first give the values for first single dimensional array. Say for example, I'll give some numbers: 4, 5, 6, 7, 8. This is one single dimensional array. Then another single dimension, second single dimensional array, 1, some random numbers I'm giving. Then third single dimensional array. So 3 single dimensional arrays I gave. Again, enclose all these three inside a separate block like this. So which becomes a 3 of size 5. I hope everybody is clear with this. Now printing of values. So printing of values, as we have seen in the previous single dimension array. To print a value of a single dimension array, I was taking a for loop and printing the values. I was taking a for loop and given a printf statement inside a for loop, and I have asked that for loop to be repeated for number of size of the array. Suppose the size of the array is 10, this printf statement has to be repeated for 10 times. If the size of an array is 5, this printf has to be repeated for 5 times. But that was in single dimension array case. But here it is a 2-dimension array case. So what I need to do is, I need to print this block first. If I have to print this block, I require one for loop. Again this block, another for loop. Again this block, another for loop. So what I have to do is, this for loops are repeated for 3 times. Just concentrate here. For this block, I require one for loop. For this block, I require another for loop. For this block, I require third for loop. First for loop, second for loop, third for loop. So again, for loop is repeated for 3 times. So we have a concept called as nested loops. So what I'll try to do is, I'll create a nested loops. That is, one for loop inside another for loop. Okay, one for loop inside another for loop. So it is going to be something like this. First for loop I'll create. Inside this, I'll take another for loop. So this concept is what we call it as nested loops. Now, what is this first for loop? Inside this, I'll take a printf statement to print. What is this outer for loop? Outer for loop is take it for first dimension. Inner for loop, take it for second dimension. Okay, just remember this simple concept. Outer for loop for first dimension. Inner for loop for second dimension. Okay, so it can be something like this. Declare a variable I is equal to 0. Now outer for loop, how much is the value? 3. So I less than 3, I plus plus. Now declare another variable int j is equal to 0. Now this inner for loop is for second dimension. So j less than 5, j plus plus. Okay, now I need to print a numerical value. So I'm going to take %d, comma. I want to print a value. Inside a, I want to print 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Then 1, 0, 1, 1, 1, 2, 1, 3, 1, 4. Then 2, 0, 2, 1, 2, 2, 2, 3, 2, 4. These are the values are going to be stored. Okay. So here, if we take this 4, 4 is of 0, 0. Okay. We take the value 5. 5 will be here 0, 1. Then 6. 6 will be 0, 2. 7. 7 will be 0, 3. 8. 8 is going to be stored in 0, 4. Then second for loop. 1. 1 is going to be stored in second row. That is 1 and 0. 2 in the second position of second row. Then 3 in the second row, third position. 4, the second row, fourth position. 5, second row, fifth position. Same way, the last one. 9 is going to be stored here. 8 is going to be stored here. Then 7 is going to be stored here. 4 will be stored here. And 2 will be stored here. So these values I need to print according to row wise, followed by column. So again, I'll take 2 dimensions over here for printing the values. First dimension, I'll mention I. Okay. Second dimension, I'll mention as j. So this will be the entire program for us to print the values. Okay. I hope everybody is clear with this concept till now. So let us execute this program. Got all the values, but only thing is they are printed in a straight line. I want to print them according to row wise. According to row wise, I want to print the values. So what I can do is, after first for loop, take another printf statement and use something called as /n, which makes the statement to go to a new line. This is an escape sequence which makes the statements to go to a new line. So I'll execute the same program once again. You can see the values 4, 5, 6, 7, 8 first for loop, then 1, 2, 3, 4, 5 second for loop, then 9, 8, 7, 4, 3 third for loop, combinedly called as a two-dimension array. Okay, then one more important concept that everybody have to remember here. If you observe these values, if you observe the output values, you can remember some concept of mathematics that you might have learned in your schoolings, which is called as matrix. Matrix is nothing but it will have the values in the form of rows and columns. Rows and columns. So, simple statement I can conclude over here is two-dimension array. Two-dimension array is the matrix. So, in the examination, you will be asked this question. Explain about two-dimension arrays. Or they might ask you something. Explain about a matrix. Matrix is nothing but a two-dimension array program. And this is going to be a very important concept for examination point of view. One more important question which can be expected in the examination is write a program for adding two matrices. Write a program for adding two matrices. That is, take two two-dimensional arrays, take two two-dimensional arrays. There is one two-dimensional array, take another two-dimensional array and add the values in the form of a matrix. Okay? Or there's also one more important question. Explain about two-dimension array, or write a program to explain about two-dimension array matrix. So anything can be asked from these concepts. So next I'll explain you how to add a two-dimension array matrix. Okay. First, logically I'll explain you. These are values. Okay. Take another two-dimension array values. For instance, I'll take a smaller program. I'll not go for such a big program. I'll take a smaller program. I'll take a matrix of size 2 by 3. Let us say this of matrix A. Int A of 2 by 3. Similar way, I'll take another matrix for performing the additions. So for remember one concept, whenever we are performing the additions of a matrix, both the matrix must be of same sizes. Okay. So let us take this as int B of 2 by 3. So I'm having two matrices, and let us give some values. Say for instance, we'll take smaller values 5, 6, 7, 1, 2. I'm not writing the index, I'm writing the values. Remember this. Okay, and here as well, I will take some values 4, 3, 4, 2, 8, 9. Now remember one thing, whenever we perform a matrix addition can be done on row wise and column wise to exactly the same value. Say for instance, I want to store the result of both these additions in this matrix. Third matrix, I want to store the result. Let us say that this third matrix is something like int C of 2 by 3. So first condition, whenever we perform a addition, matrix sizes have to be same and resultant matrix also must be same size. Now, when we perform the addition, the value 5 over here must be added to the value 4. Okay, so first value, that is row number 0, column number 0 value must be added to row 0, column 0 of the second matrix. Then 6 is added to 3, that is second value, row number 0, column 1 is added to row number 0, column 1 of second matrix. Then 7, 4, 1, 2, 2, 8, 3, 9. So resultant matrix will be something like this. 5 plus 4, 9. Then 6 plus 3, again it is 9. Then 7 plus 4, 11. 2 plus 1, 3. 2 plus 8, 10. 9 plus 3, 12. So this must be the resultant matrix values. So we'll try to do in a programmatical way. I hope you have understood the logic. I'll explain you in a programmatical way. So come back. I'll take two matrices of same values which I've given in the 2 by 3. 2 by 3. Okay. And what I'll try to do here is I'll not give the values directly, but I'll try to give the values by using a scanf. So I'll declare 3 matrices of size same, comma, C of 2, 3. I've declared 3 matrices of size same. Now, I will accept the values by using the scanf. So I'll take 2 for loops for accepting the value into A. So first for loop is 2 size and second for loop is of size 3. So I'm accepting the value into the matrix A. So I need to use scanf, not printf. Scanf percentile D ampersand of A. Okay, this is for accepting the values into the first matrix. Second matrix, and I'll take another I'll give a printf statement. Printf for second matrix, and here printf enter for first matrix. Okay. So here this has to be B. Now I'm accepting the values into 2 matrices. Then what I need to do, third one, I need to calculate the addition of A and B. For that, again, I'm taking 2 for loops. Now I'm not taking scanf. But what I'm going to do is C of I, J is equal to A of I, J plus B of I, J. That is I value and J value. If we come to the example, this 5 must be added to 4. That is 0, 0 must be added to B of 0, 0. That's why I've given the same thing, I of J. So I value and J value will be rotating, and those results are going to be stored in the same 0, 0. 0, 0, this is the index 0, 0, this is the index 0, 0, and stored in same index 0, 0. That's what I've given. C of ij is equal to A of ij plus B of ij. Then for printing, I'll print the third matrix C. Okay, and this will be of size 2 and 3. Okay, so now let us execute this program. First, I need to enter the values of matrix A. Matrix A values, and to enter. So we'll try to take the same values 5, 6, 7, 1, 2, 3. 5, 6, 7, 1, 2, 3. Now enter the values for second matrix. 4, 4, 4 3, 4, 2, 8, 9. 4, 3, 4, 2, 8, 9. Resultant 9, 9, 11, 3, 10, 12. 9, 9, 11, 3, 10, 12. Exact answers we got. Okay. So this is what we call it as addition of matrices. And this is going to be a very important program even for the practicals as well as for the theory point of view. Now, continuation to this. Here I am having three two-dimensional arrays. Suppose if I want to go another thing, so why can't I combine them into one and make it as another array? That is, if we come back to the basic concept, of arrays. Here I am declaring 5 different variables. So am I not combining them and making them as a single dimensional array? Again, I am having 3 single dimensional arrays. Am I not combining them and making as one two-dimensional array? So again, two-dimensional arrays, I am having 3 here. Can't I combine them? And make it as one array again of common type? So it can be something like this. Int a of, I need 3 of size 2 rows and 3 columns. So here one simple concept that we have to understand over here is single dimension array is combination of multiple variables. And two-dimension array, 2D, in fact we call it as 2D array, is combination of multiple 1D array. 1D is nothing but single dimension array. And 3-dimension array is combination of multiple 2-dimension arrays. Then it goes on. 4-dimension array is combination of multiple 3D arrays. So it goes on. This 2 or more than 2 dimensions are what we call it as multi-dimension array. I hope I am clear with all these concepts. So today's session I have covered with 2 concepts. One is what is a 2-dimensional array and what is a multi-dimension array. Okay. So these are going to be the important concepts. So most of the time they are going to ask you in the examination, explain about 2-dimensional arrays or write a program for addition of 2 matrices. I hope I am clear with all the things. So I'll stop the session. Thank you. Thank you very much.